Okay, recording start. Hello, dear students. Welcome to our 8th lesson. So today's topic will be about classes and objects in Python. And I want to start the discussion of this topic with the determination of such thing as encapsulation. I want you to really understand what's going on when we talk about encapsulation, because there are a lot of different determinations, and there are people that think that encapsulation is just about protection of your data. But let's think about encapsulation like combining um, your code and data together. Actually, we already saw this type of process. We have talked about Python modules. So as you remember, you have your main file, main executional file, where you have your code line by line. You use some functions, work with some data, and you have some library or package inside module. Maybe it is your file. And here you can think about this module, this file, like a bag with different data and functions to work with this data. And of course, we can import this module. Let's call it module 1, and get access to each representative of data or function using dot operator. So module 1 functions something. We can access the data and functions inside this. Maybe you can think about it like capsule. Of course, if you are biologist, it's really interesting to think about it like a cell. So you have cell with all those compartments like nucleus, different organelles here, and all you have inside is encapsulated with a bilayer of lipids. So we have a cell membrane, and all the data and functional things like peptides or proteins, we can think about them like functions, are inside our cell. And for example, to get some data from inside of the cell, we can use internal interfaces such as transmembrane proteins and other things. So you can think in that case about computer science abstraction that have encapsulation. So you have your module like a bag of data and functions, and you have interfaces to get access to the internal data and internal functions. But okay, this lecture is not about modules because we already talked about them. So we want to talk about classes. So from the word view, the class is just the same bag for the code. So you have your class, and inside of it you have your data and functions. So in terms of object-oriented programming, we call functions inside the class methods. So it will be methods, and the data inside the class will be attribute. This is just terms used in computer science. So data inside the class called attribute, and the function inside the class calls class method. Okay, pretty familiar, and it looks like a module. But the thing is that class can construct the instance of itself, and this instance called object. You can think about it like class is just a blueprint how to construct object. So we have some description how to construct object, and using this description we can construct multiple instances, and we will call them objects. So each object is an instance of some class, and this class will be a type of this object. And if you remember that I have talked about Python and data model, we all know that just everything inside the Python data model is an object. So for example, we have x equal 5. It will be in our name object data model, it will be name connected with the value 5 of type int. So this type int is a class. This is a special class internal type of the Python interpreter. But we can create our type. For example, I don't know, we will do it in practice just a few minutes later, but we can, for example, have some object with some attributes, some methods, with class, for example, student. And this is our class. And we have some student name that assigned to this object. So this will be an instance of the class that was created using the blueprint. And the blueprint is the class description. So to be more clear and to visualize the whole process, let's code something. So why I can't increase? Okay. How to create the simple class description, the simplest one. We just use the word class and a name for this class. Assume that we want to create class student. Please pay attention that there is a convention in PEP 8 that all class names are beginning with the uppercase letter, because we do not want to mess functions, methods, and classes. So the convention is, if you define the class, please start the class name with the uppercase letter. So as when we define function, we can use pass here. So this is just a class description that do nothing. And we can create an object. For example, I don't know. Using that notation, we create an instance of class student that have name Michael. So Michael will be our object. And after that, we can print type of Michael. And we can see that this is a new class called main.student. So main, it means that this class was defined inside our main module. So, okay, we have created a new class, but it is useless because it's do nothing. But not nothing, it can create instances, it can create a new object. So we have Michael, we can create another, for example, Lisa is the student 2. And here I want to show that these are two separated instances of the same class. So let's first print type of Michael and type of Lisa, and then print, if you remember, the function ID that will return the ID of the object inside Python memory model. So ID of Michael and ID of Lisa. And we can see that they are both the same class, the same type of class student, but they are different objects. Okay, what else can we do? So, where is annotation here? Okay. So this class is empty now, but you remember that class is a back with data and methods. We can add some data inside in Python. This is not a great way to treat objects, but yes, we can do it. We can add internal attributes to the objects. So how we can do it? We can say Lisa dot age is equal to 18. Michael dot age is equal to 90. And after that, please print us the Lisa dot age and Michael dot age. Where I have so okay, it prints out 18 and 19 correspondingly to the Lisa and Michael's ages. So this is a bad way to treat objects. The good way is to create attributes in the description of the class. So how to erase? let's start to somehow modify our class definition. Let's create an age value inside, and let it will be 0 by default. And for example, we will have another attributes like semester of learning, and by default it will be 1. So, and when we create our Michael and Lisa, they will already have these attributes inside. So print lisa.age, lisa.semester. It will return the default values from the class description. But okay, we do not want to use defaults. We want to create our instances, our objects, already using some data. So, for example, we want to create our students, already know their name, their age, and maybe semester. Okay, so there is a special function. So here it is implicitly hidden, but we can explicitly write it. It's called init function. So init, if you are familiar with another languages, you can call it a instance constructor or object constructor, because what it do, it gets the class description, and using this blueprint, it constructs a new instances. And by default, not by default, this is a convention that you must use the first argument inside methods of the class called self. You can use anything else here, but this is a convention that we always write self here. This is the first argument that is necessary to call the constructor. What is this argument? This is an instance. This is an object that will be substitute inside the constructor. So here, if we call Michael is equal student, this instance Michael will be passed inside the constructor. So self mean the instance that will be created. And for instance, we can create the object attributes. And to create them, we can use additional arguments to init function. Maybe we want to use name here. Maybe we can do like first name, second name, age, stipend. Looks like a legit class for the student. So first name is equal to first name. What does it mean? It means that when we create a new instance, a new object of class student, it will have an object attribute first name that will be equal to the argument of the constructor first name. So the same is for other attributes. And of course, they not need to be the same. We can use different names for the internal. For example, first and second, like here. And now we have no default constructor like this. We ought to use a full constructor that is described in init method. So if we want to create a new student, for example, student 1, we must call the full constructor that will have first name, the second name, age, and stipend. So now we have one student. If you want second student, we can call the same constructor. I don't know. Maybe in the beautiful world, Lisa have more stipend than Michael. So now we have two objects of the class student, student 1 and student 2. We can get access to the internal object attributes. Once again, it will be object attributes unique for each object. But for example, here we can create a class attribute. I don't know. School name. And this is a class attribute. This will be the same for each student. If they have not the same name inside the object attributes, because if we will have something like self dot school name here, it will return this. So the internal object attribute will be prioritized. But if we have no object attributes, when we call, so let's do it explicitly. We want to know student 1.name. Oh, first. We have no name. We have first. We have student 2 first. And after that, we want to print student 1.school name and student 2 school name. Yes. Where I have a mistake. Stipend.
Definition of function.
Yes, thank you. Michael is not defined, of course, because this is a string literal. So look here. We have different names like an object attributes, individual for each object. And we have the same school name because this is a class attribute. But if we change and create, for example, for student 2, school name will be equal to, I forgot how Stanford looks like in English, maybe like
Why A, not E? Stanford A.
oh, thank you. Oh, you see, now the attribute for school name will be the object attribute for the second object. And the most, I don't know, is it legit to say popular, but the most common error using classes and object is when you try to when you try to use attribute that is not inside object attributes and not inside class attributes. For example, student one dot I don't know what we don't have, email. So I think you have saw this error a lot, attribute error. So it means that student object of class student has no attribute email. It has no this attribute neither in the object attributes, neither in class attributes. So this is an error. Okay, let's try to work with some methods for a class. Let's create method, for example, for email. So
can I ask please a question?
yes.
If there are two functions within the main body of the class, for example, def init and def, I don't know, average grade point, how should we to type input when we create new object in this function?
Actually, I can't understand. Could you please refer?
Okay, well, if we have two functions inside the class definition,
okay,
description, I mean, for example, for this, for us, it will be init function, and for example, one more function, which will be, for example, calculation of grade point average.
okay.
How should we type arguments when we create the new object?
Okay, I will show you right now how we treat with class methods. So it's literally what I want to do here. So we have in class additional method, please get us an email for the student. Once again, remember, if you have method inside class, if you want this method to use instance of this class, the first argument must be self. So, and this is the only argument for get email, because I won't just print, for example, some formatted string like self.first underscore underscore self.second at symbol, and actually we have school name with space. Just want to fix it. School name edu. So this is a second method inside our class description. So the first method is a constructor of object. The second is just a method to get some object attribute. So this is not to get object attribute, it's to get additional information. So we combine different object attributes to show email address. So how we can call it? We have two students and so we want to print, please, student one get email. We get access to the method using the same operator dot. So we have object name dot and the name of the method. And this object instance will be sent inside this method as first argument. So it will look to this object first name, this object second name, this object school name, and it will return us the full email. So let's do it for another student. School name is not defined. Why not? Self. Okay, I forgot about self. Oh.
One more to type.
Yes. Student object has no attribute email. Oh. Where is it? Get email. Here. From where we have none. Okay, I understand. So the thing is that student get email already prints something. So it use print function to print us the full email for the student, Michael Smith at harvarduniversity.edu. And then we print the result of execution of this function. So this will be none because this function return nothing. We just want to get rid of this. Okay, so for maybe it's not correct because our function called not print email but get email. So maybe, not maybe, determinedly, we want to return the string. So because we have a name that explicitly says, please get me an email. An email is an string literal. So please return us a string. And here we want to print it. Yes, it works. So we have two beautiful methods to get access to the new data that was composed using objects, object attributes. So what we want to do next, maybe we want to use special methods. For example, you already know, I think, the method str. So just want to show in Python. For example, we have x equal 5. So this is just an int object. We can use dir to show all the methods of this object. And here we have str. So what it use for? It use for print an object x. So print of x will be just the value of x. Okay, maybe we want to be able to print our objects, just to write here, like, not print a result of some method, but print student 1. That will print all the information about this student, maybe somehow formatted. So let's create it. This is a special method. Oh, please use the conventional spaces between a method inside. So method str, of course, self. And here we want to return some string literal, but let's try to construct it. Output equal empty string. First name tab first. Oh, I forgot the new string. Second name tab second, and new string. Oh, of course, I forgot. We must use self dot first here. And of course, this must be formatted strings. Age equal to the self age. New string. And the last one, email, is equal to, and here we can use the result of the own method. So we can call self dot get email here. Yes, yes. And please return us out. So please print student 1, and after that print student 2. Okay, and we have the full information for our student inside. So one function, str, using print function, return us the full information for the student. And we can use this for the complex object. For example, you have some complicated matrices and you want the special type of representation for this. You can create an object for these matrices, and for each object of this matrix, you can use the method str to visualize matrix in some special format you want. Actually, maybe we can construct such type. Okay. Maybe you have questions on this stage. guys? Okay. So let's construct the class for matrices. Very interesting task, actually. I will delete all. So class, let it be matrix. So what is the matrix? Matrix is just a table. Let's think about 2D matrices. So matrix is just a table. When we have lines, we have columns, and we have values inside. So we want to create an object of class matrix. So please give us the shape and values. So shape will be the dimensions of matrix. So self dot I will be use x and y's. So x will be for the rows, y for the columns. So x will be equal shape 0, self y. Maybe it's better to store the dimensions here. Okay, let it be shape. And after that, we want to use all the values to construct the matrix. Let first construct. So in better way, you must first of all check if values, if len values is equal to the shape 0 multiply to shape 1, do something else. We will be talk about errors a few classes later, but here is better to use try except construction, but I will just print that we have an error with okay. So in that case, we want to create our inner matrix like a list of lists. So the inside list, outside list will be maybe better to do it explicitly using for cycle or line in shape 0 in range. Self.matrix is equal to 0 for in range 1 or G here. So here I just create a empty list of lists that consist of zeros using the list comprehension construction. So, and here I explicitly want to go through every line and for column in range shape 1 self dot matrix is equal to self dot matrix with coordinates line call is equal to values line plus call. Okay, I can use this for the default like a default value for self matrix, and if len is not equal shape 0 multiply shape 1, our attribute self matrix will be the matrix of zeros with the particular shape. Okay, I think that our constructor is done. Let's create str method to visualize our matrix. So what we want to return some string that will represent our matrix. So once again, we have out equal empty string or line in self dot in range. Here is actually here I can use without self because shape is our argument, but better way, of course, use self here. Okay, here the same self dot shape 0 or call in range self dot shape 1. Please out plus equal self dot matrix f. No, not like this. I want something like this. For line in range shape 0, please out plus equal space dot join self dot matrix line, and in the end out plus equal new string. Okay, let's try to create some matrix. M1 is equal to matrix shape will be 2 by 2 and values 1, 2, 3, 4. Okay, and let's try to print M1. Oh. Tuple object is not callable. Of course. This is a mistake. So it is about these indices. And it's about Python notation of nested lists. Sequence item 0, expected string instance int found. Okay. Join list map str. So for each element inside this list, I will use str function. Because join expects only string instances. Oh, I forgot to return out. One, two, two, three. Something wrong. We have 1, 2, 3, 4, and this is a error here. Line call equal line plus call. Here will be 1, 1, and we will have second. Okay, it's not like this. It's a line 0. Yes. Line multiply by shape 1 plus call. Yes, now it works. So let's create matrix bigger. For example, 2 by 3, I don't know. 2 by 3, 1, 2, 3, 4, 5, 5, 6. Yes, it works. So we have 2x3 matrix that can be printed. What else can we do with objects? There is such a thing like overloading of operators. Assume we have x equal 5 once again, and here if we dir x, we have this internal method called add. One called add and second called add. So this is right add. This is our plus operator. Yes, plus operator is the attribute of the type. So x is int type, so it has attribute to add something, add to right add something. How it works right and left. So this is usual add. This is the same as x dot add self and 12. Oh, sorry. So this is the same. And this thing is right add. We have some value on the left side and our object is on the right side. And it's called radd method. So why I want to talk about these methods? Because we can override them. You know that we can't sum matrices using just plus operator, but we can create this. We can create the special method for our matrices class just to sum them. Let's do it. Def add. First of all, our instance self, and we call it other. It's just a name. I prefer to use other. I think all of you know how to add matrices. So first of all, we need to it's very unusual to work without error expressions, because here I want to just start with try, but let's do it like this. If self dot shape is equal to other dot shape. No. First of all, we want to know what is the type of other. If type of other is equal to type of self, so this is another matrix. We want to sum up only matrices. Is equal type of self, and if maybe really with and self dot shape is equal other dot shape. So this is a good conditions, and we can to sum up our matrices. We can do it using for cycles. So answer will equal the 0, 0 matrix. Oh. Okay, first of all, answer is a matrix of zeros, and for E in range self dot shape 0 for G in range self dot shape 1. Oh, actually, if I use add method, I want to output not a string, not a matrix. I want to output another instance, another object, a new matrix that is the result of the calculation. So here I want my answer to be not just a list of lists, but a new instance of matrix from shape self dot shape and values self dot shape. Let's start with okay. Maybe we want to form our list. So value or new values is equal to list. And for E in range self shape 0, for G in range self shape 1, new values dot append of self dot matrix y G plus other dot matrix I G. Okay, new values is good. And after that, please return us a new object, new matrix object with shape the same as our shape and values equal to new values. I think that's good. And let's try to create some interactive program with it. So print, please. Input first matrix parameters. Shape tokens. I will work with tokens. Tokens is equal input dot split list map int okay. I will have a string of numbers. First two will be the shape of the matrix, and another will be values for the matrix. So please create first matrix is equal to new object matrix shape. This is tuple of tokens 0, tokens 1, and after that tokens 2 to the end. Okay, the same thing. The same thing for the second matrix. Second. Second matrix parameters, new tokens. And after inputting each function, I want to print first of all your first matrix print M1, and here your second matrix print M2. So let's check that all works now. Okay. Oh, not Python. Two by two, 1, 2, 3, 4. Yes, first matrix works. Second, 2, 2, 5, 6, 7, 8. Yes, it works too. So, and like a final, please print us the overloaded plus operator. So print the sum of functions will be M1 plus M2. Two by two, 1, 1, 2, 3, 4, 2 by 2, 5, 6, 7, 8. And the sum is working. 1 plus 5 is 6, 2 plus 6 is 8, 7 plus 3 is 10. Okay, so now we have a legit object for matrix representation that has overloaded plus operator, and we can use it to matrix summation. Okay, what can be done else? For example, what we want from matrices. Maybe I want to finish with matrices. The cool example of using objects is an example of rational numbers. Maybe I have time to show you how to work with rational numbers. So if you remember the rational numbers, you are special numbers where we have z here and natural numbers in denominator. So I want to represent them using a special object, because inside Python we have only int. So this is for z. We have float. It's some way try to use real numbers. and we have complex or complex numbers, but there are no rational numbers. Let's try to create an object to treat the rational numbers. How to clear all? So let's create.
Can I ask you a question about
Yes,
the previous
yes.
example? It is called the overloading of operators because we substitute the regional add to another variant of add, which is.
Oh, sorry, I forgot. So actually, that was not overloading because we have no underscore add inside our object yet. So we create a new. Yes. So in that case, it's not overloading. We just use a new method, add, like a str method. So because we have no str before to print matrices. Maybe this is my flashbacks from C++ because we call overloading there for the actual operator plus. So here we have no operators. We have object methods, and our object matrix has no method add before we create a new one. So this is definitely not overloading. Thank you. Let's create a rational class. So as always, we'll start with init. Who remember how we call the first part of the number? So the bottom one is denominator, and the upper one, how we call this? Numerator. Okay, thank you. So init have self argument, numerator, and denominator. When we want to create a new number, we want to create internal attributes, so self num and self denum denominator. I forgot actually. It is equal. The story here is not so simple because let's assume that we want to create rational numbers from some ints here. Oh, there is draw. So it will be an int and it will be an int. And we want to check some parameters here. First of all, let's check if sign, what we can do for sign. If numerator multiply denominator less than 0, then self numerator will be minus absolute value of numerator. Maybe we can do it shorter. So we start with, actually we should also check if denominator is not equal to 0. If it's not equal to 0, to place our num is equal to numerator, absolute value, and denom is equal to absolute value of denominator. If this multiplication less than 0, so actually here else we must raise an error, but we just print if this multiplication is negative, our num will be minus our num. Okay, that's all. So we have created a constructor. Let's create str. Oh, this is a method, so I must have self here, and out is equal to f self numerator slash self denom. But if you pay attention, this is not all for the definition of the rational number. So let's create some q is equal rational from -1 to q2 is equal to rational 14, 16. Oh. Where? 14, 16, please. Oh, what's going on?
The first line.
The first line, what? So please print Q1, Q2. Plus rational. str returned non-string. Why not string? Ah, okay. And this is an error because when we have a definition of rational numbers that is equal to z in numerator and natural number in denominator, these two numbers, z and n, must have no common divisors. So 14 16ths is not a legit rational number. Okay, we can think about equivalent classes, but in usual, we prefer to use the 7/8 for this. So we must implement this when we construct our class. Have you heard about algorithm of greatest common denominator? have you this on your discrete math class? Guys?
As I remember, yes.
So it's called Euclid's algorithm. And we want to implement these to get rid of common divisors inside our rational number. So we must divide the numerator and denominator on the greatest common divisor. So let's implement a GDP function inside our object, inside our class. Why? 1, 2, 3, 4. Oh, okay. GD, yeah, no, GCD, GCD, A, B. So look here, this is a function inside a class, but I have no self here because I do not want to use instance of the class. This is just a method that encapsulated in the class description. I do not want this method to work with objects. This is a special method to work with our internal data, just with two numbers to get a greatest common divisor. So how it works: if b is equal 0, please return a, else return GCD from b, a modulo b. Yes. So do you understand this algorithm? I think this is important step in your computer science career. Oh, maybe, do any one of you have questions about this algorithm, how it works? I can describe it. Okay, no questions. So we will use it, this method, inside our constructor. So please, our self num and denom, please be, first of all, we will count GCD. So use self dot, no. If we do not use self here, we can't use self dot because it will be passed as the first argument. We can do like this: class name dot GCD, like with modules, and enter here numerator and denominator. And after that, our self num will be abs of numerator integer division by GCD. And here integer division by GCD. Okay. Let's try to run it. Unexpected character after line continuation. Where is 6, line 6?
Colon after else in GCD.
Once again.
In function GCD, we need colon after else.
Why? I think that I just forgot how we write division operator.
Yes, and after else in function definition.
Here? Ah, okay. Thank you. Name GCD is not defined. Return. Here we must use the same thing. Rational. Oh. Not replace, just insert. Rational GCD. Yes, and it works. So it divide the numerator and denominator, but it's greater common divisor. Great. We can add here additional functions like multiplication of rational numbers, summation of rational numbers, and all the things that rational numbers can do. And of course, we can use this new type in our computations. So assume you have a work when you want to see your, I forgot how we call them, reciprocals, I don't know. So you want to explicitly work with rational numbers, and you can create your own type, create your own methods for this type and use it in your program. You're not limited by the internal types. So you have just a few types, int, float, complex, string, list, dict, set, but you create all the bunch of different kind of your own classes that can create instances that we called objects, and you can work with them according to your rules, and these rules will be described inside the class definition. So this was the main point of today's lecture. Okay, we have no time, I think, but I can answer your questions. Please tell me if something was not understandable. Actually, I want to compare the list of people on Lection with list of people that are not good in programming, because maybe some of you must think more about the conception of the objects and classes if they see this in the first time. Actually, this is the whole paradigm of programming, because using of objects, we just go more into the domain sphere. So we can create abstractions that are similar to the object in the real world. So for example, first our objects was were students, and we create the model for the living things, so for the students inside our code. So we just try to create our own modules that work like we want. So, and for today, I think the main word is encapsulation. How we can combine code and data inside one class definition or inside one instance of this class. Okay, I think that's all from me. But okay, today you have no lessons after lecture. And once again, if you have question, please ask. Okay, so thank you very much. We'll see you at Wednesday. Goodbye.
Goodbye, thank you.
Goodbye. Thank you. Goodbye.